And I'll tell you when it says you're live.
As opposed to Memorex.
That's right.
And well, who here, how many of the young folks would not understand that joke?
Probably. So good. I'm blacking myself out here, muting myself. Okay. Mike, the floor is yours.
All right. Well, good evening, everybody. At least here from the great Garden State of New Jersey. Most of the leadership team here lives in various parts of the state. So first of all, welcome. Thanks for taking time out of your day to spend an evening with us and learning about Project Loom. My name is Michael Rudlick. I'm one of the co-directors of the Garden State Java Group, and you know, we've been running this group under a different name until a year and a half ago. So it's been what, 21 years now, 21 and a half, I'd say. And we are not planning on stopping anytime soon. So what I'm going to start doing is share my screen and do the usual introductory slides, which now, of course, you're seeing my source code as opposed to what you should be seeing. Okay. That we don't want to see either. Here we go. Okay. Good thing Scott's not here. He'd yell at me. So, okay. So the agenda for tonight, as usual, we do a round of thank yous to our sponsors, you know, who've supported us. Talk about a little bit what's new. I'll introduce Buzz Lure. And then after his presentation, we're going to talk about some upcoming events at the Garden State Java Group. And, you know, we are friends of some of the other Java groups around the country. So you know, I'll look at what they're up to this month, and I put that on the slide. And then, of course, as usual, we'll have our Intellij idea giveaway. You need to be here in order to win. So let's see, well. All right, so our platinum sponsor is JFrog. Please take a look at their website and see what they provide. Azul Systems is a silver sponsor. DevNexus is our partner. So we work with them when they have their annual conference, usually in the spring timeframe. We have per meeting sponsors, JetBrains, who of course provide the licenses to Intellij IDEA, and Jakarta EE, or the Eclipse Foundation, for providing full use of Crowdcast to Java user groups who are interested in using them. So we did use them for a while. We decided to try some other things in the meantime. So what's new? I mentioned this last month, but it's worth noting. JDK 19 went into ramp down phase 1 on June 9th, and then phase 2, I believe, is July 20th, if I'm not mistaken. So a little bit later this month. And these are the 7 JEPs that will make up JDK 19. Take note on JEP 25 and JEP 428. Of course, Buzz Lure is going to be talking about virtual threads. I don't know if you're going to touch on structured concurrency or not, but Buzz Lure? Oh, you're muted.
Oh, sorry. If we have time for that, of course, okay. I'll try.
Okay. But yeah, that could be a whole nother talk in itself. So, but yeah, like I said, those are the different JEPs that will make up JDK 19. And I noted in green there the projects that those JEPs, you know, under the auspices of those JEPs. There's a study guide that you see here that one of our co-directors, or I'm sorry, one of our leaders, Scott Selikoff, is a co-author. That's there for that. And Jakarta EE10 is slightly delayed. It was supposed to be released in the second quarter. There are some issues with some of the specifications or the compatible implementations passing the TCK. From what I've read, Glassfish is one of them. But if you look at the Jakarta EE archives, you can get caught up on on what's going on there. So hopefully very soon we will hear more about that. So at this time, I'd like to introduce Bazlur. He's a senior software engineer over at Contrast Security. With more than 10 years professional experience in the software industry, predominantly in Java and Java-related technologies. And he was recently crowned as a Java champion within the last couple of months, I believe. So congratulations again. Outside of his regular work hours, he loves to mentor, write, speak at conferences, and contribute to open source projects. He is the founder and current moderator of the Java user group in Bangladesh. He has organized meetups and conferences to share Java-related knowledge with the community since 2013. He was named most valuable blogger at DZone, one of the most recognized technology publishers in the world. Besides DZone, he's editor for the Java Q at InfoQ. He did join us a couple months ago. So I'm happy to have him on the team. As you know, I write for InfoQ as well. It's another leading technology content publisher and content organizer and an editor. He's also an editor at Fuji.io. That's the Friends of OpenJDK for anybody who's interested. And in addition, he has published 4 books about Java programming in Bengali. They were bestsellers in Bangladesh. He's got a bachelor's degree from the Institute of Information Technology, University of Dhaka, Bangladesh, in information technology, majoring in software engineering, and he currently lives in Toronto, Canada. So, okay, I made it through that. So without further ado, Bazlur, we're very happy to have you here today. We're looking forward to hearing more about virtual threads.
All right. So let me see if I can share my screen. Thank you, Mike, for your wonderful, presentation as well as introducing me. Thank you. Thanks for that. Let me know if you can see my screen.
Yep.
Though. Okay. So it's a claim. I'll start with the claim, and I'll definitely try to demonstrate that first, and then I'll go into actual talk, which is creating a million virtual thread using Project Loom. So I'll first try to create a million virtual thread. It will be a small, quick demo, and then I'll go into the stuff that I want to discuss with you. So it could be it could be discussion, since we are all here. I'm sure pretty much everyone knows to some degree what is Project Loom all about. So you can contribute to this discussion as well, by asking questions, and also, if I make any mistakes, you can definitely give me feedback, and it can be interactive as well. So please do that. And I'm pretty sure I'm gonna make some mistakes while I'm speaking. So yeah, all right. So that's totally unrelated slide, so I'm gonna skip that. Okay, so what I'm gonna do is, I'm gonna claim. So I've started with the claim, which is with the Project Loom we can create millions of virtual thread, and in fact we can do that. So before before explaining anything, I'm just gonna run it. You can see over here, I have already ran it previously, and can you see this output, by the way? So over here, I was able to create 13 millions. So 13 million is a long, it's a really big number, but many of them are already garbage collected. So this number doesn't mean anything, but ideally we could do that. So that's a claim, and that's a demonstration that which we in fact can do that. All right, so that's the demo. I didn't run. The reason I didn't run, because if I run it and it consume all this memory of my computer, this streaming might interrupt it. So that's why I didn't run. But I'll run some of the other codes. All right. So before going into the further, I want to do the what do you say, before taking off, we do the safety briefing, right? So that's what it is. Agenda. I'll try to put some context over here, what is about Java concurrency, and then I'll go through what are the benefits of, how virtual threads comes into the scene. And certainly I'll share some limitations if we, if we can, in fact, find. There are certainly, so I'll definitely talk a few, and probably you will also be able to notice some of them while you are, listening this talk. All right. And the other thing is, this is going to be extremely high level. The reason is the virtual thread is still new. It's under preview. It's not out there, right? Nobody is using it in production. So unless we use certain things in production, we are not, confident about that, right? When we're going to use it, we'll find a lot of problems. So this is certainly, still work in progress type of a project, which is Project Loom. So we keep that in mind. A lot of things can change and will change, in fact, in future. All right. So before, like I said, I'm gonna set the stage first before going into the Project Loom, which is what is thread all about. Thread is something that that's where we do concurrency in Java. It's here from the day zero. That's one of the reasons why Java is popular. And when Java introduced that, some other programming language probably was not doing that easily. Probably it was in C++ arena, but it was difficult, definitely. But Java made it simple and it made it easy. So that's why it became very popular. All right. So in nutshell, thread is, we can say that in Java, thread is an execution environment. So whenever we write a code and execute a code, it is executed by a thread. So that means if we have more threads, that means we get more execution environment. And when we have more execution environment running simultaneously, that means we can do more things simultaneously. That's the whole thread in nutshell. And that's how we use thread in Java. All right, moving on next to the next slides. Okay, so like I said, I'm gonna say, you already know all of this already, but I want to do the staging first. So this is how we usually, traditionally or classically, create threads with the thread java.length.thread class. Maybe not. Maybe in production code we probably don't use this. We probably use executors and some other ways. But classically, this is how we create threads. We create threads with the inside constructor. We provide runnable, and with the lambda expression, we can definitely do we put lambda expression as well, and then we start. And if we need to wait, we do join. So this is the classical picture. All right. So few things we have to keep in mind, which is Java threads is basically a wrapper of a operating system threads. We can call it native threads. And if you do the thread dump, you'll definitely able to see that. So there will be this is a number which is basically mapped. The idea is Java thread with the native thread is 1-1 mapping basically. So it's a thin wrapper. All right. So Java doesn't have, until Java 19, of course, have a own way of expressing thread, right? It basically run everything on a native threads. All right. So that's the idea, and because of that, it is one of the expensive construction in Java programming language, because it takes some memory which is outside of heap, definitely, and there is some context switching, and also the thread start are considered inefficient. That's why we introduced threadful, right? We probably know already about that. So now the question is how it is expensive, right? If we want to create a million thread with this native thread, or Java thread, whatever you call it, if you want to do that, how many memory it requires? If you calculate, if one thread requires 2 MB, then 1 million thread would require like 2 TB of memory. That's something like pretty expensive, right? Or probably not, close to impossible. Theoretically possible, maybe, but in practically, that's not an even possible solutions. So now question is, why do we really care? I mean, why do we need this amount of threads? Do we need them? That's the question, right? Well, there is a reason for that. So the reason is, I mean, modern, web applications, what we do in modern web application is, when users send a request, we pass that job to a thread. So the model is pretty much, one request per one thread. So that's how, our modern applications nowadays runs. I mean, there are other alternatives. I'm not going into that, but think about it. Serverless specifications runs, through this paradigm. So whenever we send a request, we pass it to a thread. And if we have a 4,400 threads in a web applications, that means at a time our throughput would be 4,000, because that's the number of concurrent connection we can handle. But the problem is, so we are sort of our throughput is limited by the number of thread we can have. I mean, we can have more threads that also increase the, theoretically increase the number of throughputs, but we can't we cannot create as many threads as we want. Although the the modern OS can handle like millions of concurrent connections, right? So if we theoretically, let's say, if we have a server that can handle like millions of concurrent connection, if we have million threads simultaneously running, does that mean we can have that much of throughputs? Maybe theoretically, but for now, let's say this is the case. So what's the bottleneck basically? So bottleneck is basically the number of threads we can have, and that's the limited. So threads are basically limited. I have done a simple code. It's a demo. I ran on my computer. I'm not going to run it over here, but you can take this code and you can run by yourself on your computer. And this will count how many threads you can create on your computer. So I did this test and I was able to create like 16,000, right? So that's definitely not much compared to the amount of concurrent connection we can handle. So again, that's a limitation. And the other thing is, when we are handling the concurrent connection, most of our communications are in a way IO driven, right? I mean, it gets request from a client, and then it does certain things. For example, it does query on database. It also calls other services. So there's a lot of waiting while it does the operations. So let's say we have got a request and we give it to a threads, and pretty much most of the time the threads basically waits are blocked by other operations. And so let's say we have 4,000 threads and we have got 4,000 connections. That means these 4,000 threads pretty much are blocked to some degree for other operations, are waiting on some things. So if we add more threads, probably it can increase the throughput, but again, there is a limitation. We are limited by the number of threads we can have. So even though we can add theoretically a lot of threads, it doesn't solve the problem. So yeah, that's the scenario with our current situations. So for that, I have created a small demo. I'm just going to show you that code. I'm not gonna run it. The reason obvious. It's probably you can. It's simple code. It's a server socket that's it's just gonna wait for a connection, and then when connection is when it gets a connection, it will send it will handle that connection. So that's what it is. So this one is single threaded, but this is not that useful. The reason is, I mean, a web server can only handle one request at a moment of time. That's not a useful scenario, right? We can transform this into a multi-threaded web server by adding executors over here. And you can see, I mean, the way whatever I have saying so far, which is I mean, the scenario of our modern web applications, right? We get a request, and then the request gets served by a thread. That's what it is doing. And then now we have a limitation over here because we have an upper limit of threads, right? We can have like 400 or maybe let's say 1,000 threads of a server, and so we always limited by the number of threads we can have with on a web server, even though theoretically we should handle a lot of connections at a moment of time, because our operating system can handle that. So that's why I'm going to share this code with you if you would like to test it by yourself. So the idea is to test it locally. What I did is I have created a simple applications that send a request to this server, and it doesn't do anything. It just send a request and it get connected. So whenever we get a request, it will create a new thread and it put in the cache thread pool. And after a while, you will see you'll get definitely some kind of error, and it will not be able to handle that. And application will be crashed definitely if you run this code, because there is a limit. You cannot allocate as many threads as you want. So this piece of code, which can be easily fixed if we just change it like this. It's the same. This one and this one's pretty much same. I haven't done a lot of changes. Only over here, I have added a new executors, which is new virtual thread per task executors. And this is going to solve our problem, and this code will run just fine. So this is interesting, right? What does it do? What do you think? Anyone? You can. I guess you can. If you don't want to speak out, you can just write on the chat as well if you have an opinion over here so far. So far, what I have said over here are pretty much the context of virtual thread. So new virtual thread per task executor, it's create executors for virtual thread. So whenever we submit a task, it creates a virtual thread and hand over the job to the virtual thread, and virtual thread does the job, and then it garbage collected. That's the idea. So to keep the consistency, all right. I mean, earlier we used to have the executors. We'll just change it with the virtual thread task executors, and all the other code will remain same. Only the impact is different now. Earlier it used to work with this native thread. Now it will work with the virtual thread. So and this is going to solve our throughput's problem that we are discussing. Okay, so from now I'm gonna speak about virtual thread. Let me know if you have any questions so far. All right.
So Buzzlore, I don't know if there might be a good time to do a poll question.
Sure.
Barry,
you can do that. I can drink a bit of water as well,
yeah.
if that's what you want to do.
Barry, are we ready to do that, or?
I have just launched the poll.
Okay, cool.
Okay, great.
Yeah, I should have warned everybody about that. We like to see what's on your mind, to help, make these, make our content and what we, go out to seek to provide for everybody. Especially when we are looking to go back into in-person meetings at some point and provide a hybrid approach. So. Kansas City and Chicago have already been looking into that. So,
all right, it looks like everyone is participating on the.
We have the. Oh, there it is.
Polls.
Oh, wait.
So, 10 out of 12.
Oh, how come I'm not seeing it? That's weird.
You're not seeing the poll?
No, but
I can see the
I
poll.
set it up for everybody but you, Mike.
okay.
Only thing is I cannot participate. I guess
We've
that's
got
okay.
we've got 10 participants, so I'm going to end the poll
Okay,
at
that's fine. As long as
with any luck. You know what? Let me do something first before I do that.
By the way, I was not able to participate in the poll.
All right, I'm going to end the poll, and with any luck, I'll be able to share the results. Here we go.
Okay.
Could be the
Looks
result.
like, yeah, I can see the poll. Did you want to speak out? I mean, some of our audience probably, can see it, especially those who are on YouTube.
Members of our audience, can you see the poll, the results?
Yes, we can.
Good, 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 good.
for some reason I can't, but that's okay.
Well, like I said, Mike.
Yeah. So,
All right.
It looks like every question, almost every question is, more or less even split among the responses, except most people have heard of Project Loom.
Okay, that's great.
That's a
So
good
I
thing,
don't have
yes.
to do a lot of work over here since everyone knows what it is. I'll rather ask questions and maybe get benefited from that.
All right, great. Thanks.
All right. So yeah. So now, now that we know the stage, we know the context. We want to get more throughputs and how we can achieve that. And we just at this point we just know that Project Loom can in fact allow us to do that. So let's go into about the virtual threads a bit. How can we create and how it's created? Okay. So far, we had a way of creating threads that we have seen earlier, right? We can create a threads with the constructor, which is new threads. And now we can have another way of creating thread, which is called virtual threads. So there is two kinds of threads. One is, and we can divide them into two sections. One is the classical thread, which is we are used to. We can call it platform thread or career thread. Basically, these are the real native threads, and the other construct is virtual thread. That's we are getting introduced to. So there's two kinds of threads. From now on, I'll say the platform thread is the native one, and the virtual thread, which is new kind of thread that we are discussing over here. So, all right. So creating virtual thread is easy. We have a simple factory method over here, which is thread.start virtual thread, and you can put a lambda expression over there as an argument, and that's it. It will immediately create a virtual thread, and if you need to join, you can just join. So that's the idea. It's easy. The other way is you can do thread.ofVirtual. It's also a factory method, and .unstarted. The first one is pretty much start immediately. So if you construct virtual thread with this, it will start immediately, and then it will execute at some point, or maybe immediately. The other one is if you don't want to start that immediately, you can use this factory method, which is thread.ofVirtual.unstarted, and then you have to start definitely. So here's the thing: as you can see, I have printed the thread.current thread, and it printed the current thread, which is virtual thread, and it's running on a fork join pull, fork join pull. And I'm pretty much sure that everyone knows what is fork join pull, right? I mean, it's a bit different than the traditional executors. The basic difference, the high level difference of fork join and executors is executor have a wait list, like it has a queue inside, right? And it has one
You're
queue.
not hungry?
Sorry, hey Mike, were you saying something?
No, I think someone else may have had their mic on by accident.
Oh, okay,
So
that's okay. So the difference, high level difference from the executors and the fork join thread pool is, in the traditional executors there will be a queue, and the whenever we submit a task, it goes to the queue. And if we have like 10 threads in these executors, all of them are going to pull work from this queue, and there will be some contention, right? So everyone would try to use take method. Let's say if it is a blocking queue, everyone is going to take the block, call this blocking queue. So there will be some contention, and the forklift pool is, on the other hand, is a bit different. Each thread keeps a queue inside them. So whenever we submit a task, it's get distributed to each thread, and we don't have that contention. So that's a bit performant. And also the other thing is, since everyone has its own queue, one thread can in fact finish their task, right? If it finishes their task, it can steal someone else's task. So that's how work stealing algorithm works. So that's the basic difference of forklift pool and the rotational executors. All right. So I just wanted to say that. I guess pretty much everyone knows about that. All right. So virtual thread runs on basically a forklift pool and on a carrier thread or a platform thread. So with the name, we can understand that this is a Java construct, not an actual thread basically. So all right. So now that we have a nice way of creating virtual thread, we can also create our traditional, which is classic platform thread using similar pattern, which is the factory method thread.opplatform.unstarted. So it just they added that to keep the consistency of how we can create threads, and I thought it's interesting. All right. So all right. So one interesting part of having virtual thread is, let's say you have a virtual thread which is running for a while, and then it get blocked or it gets suspended, and it was running under a platform thread, and when it's suspended, so other virtual thread will take place and will execute by that platform thread or user thread, whatever you can call it. So next time when the same virtual thread which was suspended can be resumed, and it will probably end up in different platform thread. So that's the interesting part. Basically, the idea is we have a forklift pool, and let's say we have like 10 thread or 9 thread over here, and we have a millions of virtual thread, and everyone will get some time to execute, and then it will suspend it, and some other virtual thread will take that place, and it will execute for a while, and then it will suspend it, and other thread will take that place. So that's the idea. Native thread basically going to execute those virtual thread. I have a small demo over here that I can show you, which is over here. Let me know if you have any questions regarding the code base. I can explain that bit. So over here, what I did is I have created 10 virtual thread. All of them are unstarted. And what I did is, by the way, let me know if you can see the screen. Otherwise, I'll increase the font.
Yeah, it looks good on my end, Aaron Basler.
Okay, so what I did is it's a single virtual thread, right? And it just executing a few code. Like if it is a it just print the first current thread and sleep for a while, and then print it again. That's it. It doesn't do anything other than that. So if we run it, so let me see if I can show. Okay, so there's one thing that you have to know, which is it's a preview feature. So you definitely have to add this flag whenever you run it. Otherwise, you will not be able to run it. Okay, so let me run it now. So you can see the first one in the first line. This is the same virtual thread, right? So this one executed by the worker 1, and then this line is executed by the worker. Sorry, first one was worker 1, and then second one was worker 9. So same code, same virtual thread is executed by two different platform thread or native thread, whatever you can call it. So that demonstrates that virtual thread can jump from one thread to another thread. Basically, it's a portion of code. Whenever it gets the blocking operation, it just it just suspended, and then later it is resumed. And whenever it resumes, it's wait for its chance. So that means the fork join pull is always running, and the threads inside the fork join pull are always taking a virtual thread and then executes, and then when it gets an blocking operation, it just suspended. So that's the idea. Let me know if you have any questions so far. All right. So like if you want to run it, you definitely have to enable this preview feature, like I showed you, since it's still in preview. All right. So next thing, what I want to share with you is how virtual thread basically works inside. This is going to be extremely high level. So it uses a concept called continuation and then scheduler. Scheduler is I already told you, it's a fork join pull, and the new thing would be continuation. So continuation is it's an interesting concept that's been added in the project Loom. Before I explain it, let me show you a demo rather. So that would be easier. I think that would be easier to explain. So there is an example over here. So by the way, continuation is it's not easy to run continuation code because it's an internal project. I had to really work hard and search it how can I run this code and show the demonstration, because you are not supposed to run any code from the from the internal package ideally, and it's not easy. So and you have to add this line whenever you want to import a internal package. So that's interesting findings. All right. So what it does is over here, I have created a scope of continuation, and I've created a continuation over here. Just follow these three lines over here, right? So I have added a one line, which is one statement, and then there is another statement, there is another statement. So there's a 3 line of code. And then over here, I have I've created another statement, which is a print statement, start, and then I call continuation run. So basically the code start executing from here. So it will print start, and then it will call run. So the execution point would be over here, which is it's going to run, execute this line. And then the second line over here, I call yield operation. So what it does is, it suspends this execution from here, and it immediately comes back over here. So that means if I call start and then call run, so it will first run, execute the start, it will print the start, and then it will print the current thread, and it will come back over here. So now the question gets to be, it's a question, it's a quiz. If I call this continuation.run, which line will be printed? Anyone? You can type on the
C2.
chat. Okay. Okay, all right. So, okay, let's see. Let's run it. I might struggle running it. Okay, so it looks like I was able to run it. So yes, it's correct. Right, it's gonna run in execute C2. The idea of continuation is, at an arbitrary point of time, it can suspend an execution and then start immediately from there. So that's an interesting idea. So what virtual thread it does is, when, let's say we have a virtual thread and it's executing something. And then at a certain point, we have got a blocking operation. Let's say I call a network operation, or I have started a IO operation. It will immediately, yield. It will suspend the virtual thread, and it will get suspended. It will just stay in the memory. That's all. Virtual thread will not consume any CPU anymore. And then later, when the IO operation is done, it will wake up. It will wake up, and then it will start execution from where it was suspended. So that's the idea in virtual thread. That's what happens from a very high level view. So idea is that's why it's extremely good for blocking operation, and it's not good. Virtual thread is not ideal or good for for like CPU operation. It's definitely ideal candidate for IO operation. So because that's why a lot of API has been changed in JDK 19 so that they can use this continuation feature. So whenever there is a socket operation, IO operation, or network call, it will suspend the virtual thread, and when the IO is done, it will resume the virtual thread. So that's where, let's say I'm calling a network operation with let's say I'm going to download 10,000 images, right? And so I'll start a virtual thread, and then it immediately blocks. It's a blocking operation because I'm waiting on a network operation. This virtual thread will suspend it, and another virtual thread will take that place. And so the native thread it's running on top will continue running. So although we are blocking a lot of virtual thread, but there is no no cost associated with it. It's just suspended. It's just using the memory. It's just residing the memory, but it's not consuming any CPU. Rather than let's say, for example, have 9 thread. This 9 thread actually continuously consuming the CPU. That's all. So that's why it's extremely cheap and it's free, pretty much free. All right. So that's what it does. So the two concepts, one is continuation and then definitely scheduler, which is for example, this two concept was virtual thread works on top of these two concepts. All right. So I just I wanted I just added same idea in this slide. So I'm going to skip it. So another interesting thing I wanted to show you in the code, which is, let me, if I can find it. Let's say thread.sleep. If we go into the thread.sleep method, you can see over here, I have a new if blocks. It's a code in the JDK, right? And the traditional one is basically sleep.0, right? Which calls which is a native call, right? So it really sleeps, it does sleeps. But when we call the sleep on a virtual method, a virtual thread, it doesn't do that. It does something else. So let me dig a little bit into the source code and find what it does. So it goes over here, park nanos, and then do parks nanos. Sorry about that. So over here you can see EL continuation. So that's what it does. So over here, even when it goes to sleep, it doesn't really sleep. It just suspends the virtual thread, and later it comes back. So even sleep method it's not CPU consuming. It just gets suspended. So similarly, any IO operation is going to whenever there is a blocking operation, the virtual thread is going to virtual thread is going to be suspended. That's the idea. So far, whatever I have shared with you, we can take one thing, which is virtual thread is really cheap. We can practically get it free, and we can create as many as we want. And if there is a blocking operation, we can definitely use blocking operation with this virtual thread, because if it is blocked, we don't care. It doesn't consume CPU. CPU is doing other things. It executed other virtual thread. So we are fine with that. All right. So there are some other languages, they have a similar concept. I don't have experience in those programming languages. For example, it has been called Kotlin, Go, and somewhat in JavaScript, Pythons, maybe Ruby's, but Java didn't really have it until now. So it's a great thing. I'm so super excited that finally Java has this interesting stuff that we can definitely I'm really waiting when it's going to be added in JDK finally, not in preview feature. So I definitely want to test it. All right. So like I already said, so virtual thread doesn't really consume CPU while it's sleeping, and that means we can really create a lot of virtual thread, and they're going to be suspended when there is a blocking operation. All right. So before going to the benefits, again, if you have any questions, feel free to share. Also, hey Mike, if you want to do the referral now, that's also probably you can do that now.
We usually wait till the end, the end of your talk, and people can fill out the form while I'm going through the rest of my slides. Yeah, but we could do another poll. I think we have another one ready to go.
Oh, okay, sure.
We do not have another poll ready to go, but I do have a question.
Okay.
Sure.
What's the most compelling reason, or the three most compelling reasons for having a new set of classes and methods for virtual threads, instead of using the existing set and just saying, hey, let's make these threads virtual as opposed to OS?
Okay, so I can try to answer that, but I'm not sure it's going to be accurate, but I can share my experience. The reason would be, so we don't want to throw away the way we write threads, the classical threads, which is, we don't want to replace the classical threads with virtual threads. We want to keep that as it is. The current behavior, which is, the platform threads, right? And on top of that, we can also add this new functionality, which is virtual thread. The reason would be, if you have a CPU intensive work, you're probably not going to use virtual thread. Virtual thread is only suitable when you have a blocking operations, because let's say, because virtual thread run on top of a platform thread, right? And if you run a CPU intensive thread work on a virtual thread, so virtual thread will take a platform thread, and it will keep running, keep executing, because it doesn't have any reason to block, get suspended. It will not block. So other virtual thread will get starved. So the reason is, so we want to identify only those, for example, modern web applications. It's basically network IoT event. We call microservices, a lot of microservices, and we call database operation. So these operations can be served with virtual thread, but if we want to do calculations, CPU intensive work, we definitely want to keep using the way we use threads. So we want to keep have both way of doing. So that's the idea. That's my thought process, but there are probably other compelling reasons which I don't know.
Okay, thank you.
All right. So there's certainly a lot of benefits over here, which is, first of all, like I said, threads are cheap now. We can create as many as we want. And the other thing is, the limitation that I discussed earlier in this before, while I was setting the context, we can go back to the request per thread style of coding in server side. So if we want to allocate million virtual thread with million connection, we probably theoretically can do that now. Technically, I don't know how it's going to be, because I haven't done that experiment, and it's not until it is in production. Probably no one will be able to say confidently, but theoretically it's possible that we can definitely have millions thread running, virtual thread running, serving millions of connections. So from that, we can definitely conclude that we will have more throughput now. So yeah, that's huge benefit. And like I said, virtual thread get automatically suspended when it's a blocking operation. That means even though we have a million of it, doesn't matter. So virtual thread is pretty much similar to the regular thread, classical thread. It support thread local variable, synchronization, thread interruption, all of those things. And you can take thread dump as well. So it's pretty much the same. And now, since blocking operation is not a problem anymore, you probably don't need reactive programming. I mean, reactive programming is fine, it's nice, it's attractive, but sometimes it becomes difficult as well, because when you read code, especially, it's difficult to reason, so, and then the benefit that I see is our our way of writing concurrent programming is much easier compared to let's say I'm writing. I'll show you a demo over here. So let's wait for that. And secondly, there's no need to maintain thread pool because we don't need it anymore. So whenever we need a request, whenever we need to submit or execute a certain port of code, if it is a blocking operation, we'll just hand over to a blocking operation, virtual thread, and it will execute that portion of code, and then it will die, and the garbage collector will collect it later. So that's the benefit. Okay, so there is a quiz for you, and I'll show you a demo for this as well. So there is two code, and this two code ideally does the same thing. It basically download 10,000 of emails from somewhere. The questions gets to be, which one do you find better readable, and if you were to given a chance, which way you will write code for that for that functionality. The idea is you have to download 10,000 of images from somewhere. The left side is A and the right side is B. So which one, A or B?
So you're just asking about readability as opposed to, right?
I mean, you can choose other region. I would say, which one would you, which way you would write code for? Readability is definitely one aspect, right?
Right. I mean, I kind of like the streams, using, A. But of course, what is that? Try with resources, is relatively new as well.
Okay, so try with this. Let's forget about the first line.
Yeah.
Just give attention to the code inside this curly brace.
Right.
So
so the left side is reactive.
right.
Yeah, that's completable future. Yeah. Okay.
And then the other aspect is, let's say you have this code in your code, the left one, and then there's a new junior developer comes to your company, and you have to explain him that this is the way you should do. How you are going to explain that? Which one is easy to explain?
Oh, explain. Okay. Yeah.
The right is just more imperative, right? It's like this happens, this happens, this happens.
Yeah.
Right.
I saw you put in B, right, Jonathan?
Yes.
Yeah.
So
I think it's more readable.
Yeah. So that's the conclusion I wanted to draw over here, which is, now we can definitely, write code like the right side, which is imperative, but then it can do the job. With the virtual thread, we don't need to worry about, we're just running a for loop, right? Iterating 10,000, we are submitting 10,000 tasks, and it's fine. I mean, if it was not about the virtual thread, if we didn't have virtual thread, we'll probably, we'll definitely try to use it in another way, because after all, at a time, let's say this one, right? Let's say we are doing on executors, and executor has a 10 thread, and at a point of time, it can only handle 10 connection, right? And once 10 is done, then only the other 10 will come, and they'll execute. So it will take a long time. But with this virtual thread, I mean, we submitted a task, it's created a virtual thread, and then it's blocked. No, okay, it's blocked. No, we don't care. I'll create another virtual thread to do another job. So I'll keep doing it until we have all this. The for loop is executed, even exhausted. So I have a demo for that. I can show you a quick demo. Let me see if I have it over here. I have it somewhere. Let's see if I can find it. Okay, so that's it. That's the code I wanted to show you. So over here, what I have is, this is an interesting website where you can download random images. So what I did is I created 1000 URL with the index. Basically, it's a random. You can add a random number, and it will give you a random image. So over here, what I did is, first of all, I created with the traditional, new fixed thread pools. I submitted, and then, then wait for all of them. So this is again similar things in a for loop. I submitted all of them, and then wait for results. So over here, I have done the same thing. The only exception is I'm using a new virtual thread per task executors, and the result is definitely interesting. Over here, I have some results. So first of all, I have, so the first one is for 100 images. Maybe I can run it. Let's see if I can run it. Only I'm worrying about that if connection doesn't drop. Let's see. I always have to add this enable preview, otherwise it doesn't run. So the idea is, I'm starting downloading thousands with fixed thread pool, and in the fixed thread pool, I have like I have 100 threads. So let's see how long it takes. It will take some time though. Probably I shouldn't have run it. Now that let's wait. I mean, the difference is really huge. For example, over here with the thread pool, it took about like, you see over here, it took like, 33,000 milliseconds, and then with the virtual thread, we have it took only 3,000 and 4,000 milliseconds. So the result is definitely you can compare the result, right? It does the same thing. It download a lot of images over here. So all of them are random images from a real server, right? So because it's a blocking operation, right? So if we use a native thread or regular thread, classical threads, most of the time this thread is going to wait or blocked. So it will not do anything, just gets it will be blocked. All right. But if we have a virtual thread, I don't care if it is blocked. My threads, executing other virtual threads. When it is done, it will notify and it will resume and does do the job. All right. So there is a question if there is a GitHub link. I don't have it, but I can share that later if you want. All right. So so you can see the benefits pretty. All right. So this is the first portion of talk material I wanted to demo and to share with you. There is another part which is about structured concurrency. You tell me, do you wanna I have time. I can definitely share some of those as well. But
Yeah, absolutely. If you have a few minutes to go over structured concurrency, it is going to be part of JDK 19. So.
Yeah. Okay. Sure. All right. So we got all these benefits, right? I mean, it's really interesting. We have many benefits. So it also opened another door, which is structured concurrency. Structured concurrency is it's built on top of this virtual thread, the concept. So let's talk a little bit about what it is actually. What is structured concurrency at all? So it's going to be extremely high level. Who remember go-to operations? Mike, do you remember go-to operations? Have you done any coding with go-to operations?
I'm sorry, what was the question again?
Do you remember go-to statement?
Code. Oh, like this. Oh, you mean, okay. All this is like Fortran or something, right?
Yes.
Yeah. I remember. I'm old enough to remember that. Yeah. So, yeah. Yes, and go-to is evil. Yes. So it's copy, paste, and edit, but that's a whole nother story.
All right. What I'm trying to say is this go-to statement, why it was the reason was, whenever you want to read a code, it goes in all sort of ways, and it's difficult to keep track of, right? And it's also difficult to, debug as well. So that's why there is a, new paradigm in 1960, came, which is structured programming, so that we have now, block, we have loop, function call, the code are structured, so we know we can reason about, like say we can reason about function call, and we can do loop. So all those things, it's definitely better than go to statement. So similarly, the idea is structured programming. You can think of the same concept. Our traditional concurrency, what we have is like go to statement, and then now we have a structured concurrency, which is like structured programming. So that's the context, basically, showing this. All right. So now let's talk about this method. So over here, what it does is, I have a method over here. It's an example of a structured code, right? It's a single-threaded environment. It's executed sequentially, right? So the fetch first, the find user will be called first, and then second is fetch order, and then we'll construct the response and return. So what if the find user fails? If find user fails, the fetch order will not be executed at all, right? So it will, the handle method will be, pretty much fails. So it works like, this method works like an atomic operation. Anything fails inside, a whole thing fails. So that's the, it gets give you a good call stack in the thread dump, or so you can even debug particularly where it fails and which line. So it's easier this way. But the only problem with this same thing, if we run write this code in a concurrent environment, for example, find user will be another another environment, another let's say find user will call a different service, and fetch order call a different service, and since this is a asynchronous operation, we can put those things into two different thread, right? So that we can get a faster result. So that's what usually we do. What we do is we submit a find user into a executors. So the idea is two threads is going to run simultaneously, and then when we get the result, we'll construct the response. Now the problem is, what are the problems with this this model? It works, right? The problem is now these two methods, right? The first one and second one, execute concurrently. That's okay. That's what we want. But they can succeed independently or fail independently. So if find user fails, fetch order will not know about that, and it will still execute the fetch order, which probably you don't want to know. And let's say the handle operation is executed by another thread, and it interrupts. while it's executing or waiting on it, it got an interrupt. It is still going to, execute this find user and fetch order. So they are going to, they're pretty much independent, and as a result, it's becoming difficult, to debug, because the call stack is going to be in two different threads, or completely unrelated threads. And although the code looks like imperative, line by line, but it's on our mind, right? In ideally, when it's getting executed, it's on a completely different order. It could be completely different order, and could be completely different stack. So those are the problem. And the solution would be, if we could do something like that, they work like a atomic operation, something like this, which is structured programming, right? If find user fail, then we probably don't want to execute the fetch order. Or if it is interrupted by the parent, then we don't want to execute any of those. So those are idea. I mean, if we in the call stack we want to get it, what do we say? In a clear stack, so that we can debug and we can fine tune later. We can find the problem. That's what you want, and that's what is structured concurrency is about. So JEP 428 does exactly that. It gives you a way of structuring your code so that it becomes structured. The concurrency becomes structured. So now this code, it creates a child-parent relationship between the invoker method. For example, the handle method is going to execute it by a task, and let's say it's a parent, and the find user and the fetch order is consider them as a child. So there will be a child-parent relationship. If parent get interrupted, child will be interrupted as well. If one of the child get interrupted or fail, then whole things will be interrupted, and that way we'll get a hierarchy in the thread dump, and it becomes easier to debug. It becomes easier to reason about. Now this whole code is in an imperative and serial. So the benefit is before virtual thread we were not able to do that, because all thread is independent, and if one thread is blocks, that's a problem. Blocking operation is always a problem. Now we don't, because we have to wait for it, right? For example, over here, scope.join, we have to wait those two to finish. Since if we want to block a certain things, we don't care, and blocking operation is not expensive anymore, we can do that now. So that's the way virtual thread is basically benefiting this project, which is structured concurrency. Now we can do that. So it's still in incubator. You can definitely try out. So it's not even preview. So there are a lot of things going to change. It's continuously going to update it, but I think it's an interesting project, and it's definitely when it's done, I'm looking forward to use it. All right. So you see, there are a lot of benefits now. Error handling become easier because of short circuiting, right? If either of one fails, the task will be cancelled, and clarity in code, and we definitely have observability, because in the thread dump we will get a hierarchy. So there are various benefits of having it. All right. So yeah, that's an extremely high level view. Yeah. So let me know if you have any questions so far. Sorry, I'm sorry. Stop play from the current slide. Okay, so Ron Plessler is the person behind all this effort. So you can definitely, he in fact share a lot of information inside .java, even in Twitter. For example, I coded this. And there are certain limitations. We'll go into that later. But yeah, that's all I wanted to share so far. Yeah, let me know if you have any more questions.
Hey, Balzer. So, Basler,
Sure.
really interesting. I learned a lot. Just one question. I think you answered it. So, in terms of like the differences between these virtual threads and the threads we're used to, the native threads, what are you calling them? I think you indicated that from a usage perspective, there's almost like no difference. We all know about the thread life cycle, and how do you start a thread, how do you stop a thread, the waiting, and then the synchronized methods and how those work with threads and things like that. All that is pretty much transparent if you're using the virtual threads.
Pretty much, but there is some caveat which I'm gonna share with you soon. But yeah, I mean, we can say that from a high level, perspective, it's pretty much similar. I mean, even though if you're creating virtual thread, you're gonna get a reference of the thread, the traditional thread, right? Let me show you that. I'll show you a demo.
While you're doing that, I just want to let people know that there is a link for signing up to participate in the giveaway for Intellij idea. So just if you want to take your chance on winning a 1-year license to Intellij idea, there's the form right there.
So sure. So that's the way we can create a virtual thread, right? Unstarted. And if we get a reference, we'll definitely get a thread, right? The same thread. And if we change it to off platform, say it just it's just a different method, but it returns the same thing. So for the virtual thread, we don't have a different class all inside this thread class. So ultimately, from a user perspective, it's the same. And some of the behavior we have, like you said, synchronizations, other things are pretty much similar. Though there is a caveat, which is let me share about that. So there is a problem with the synchronization, right? So idea is, let's say virtual thread runs on a native thread, right? I mean the platform threads, and the virtual thread can be pinned into the into the classical thread. When it does when it does. So it does when it calls a native thread, native call, and the other one is if we use a classical synchronized method. So what do I mean? What do I mean by that? So I'm going to show you an example, right? So before explaining that. So over here, when I showed this demo, let me run this code once again so that I can reason about that. So you see, say this thread, right? This is a virtual thread, and one thread is running on top of a platform thread, but then same code. This line runs on a thread, and this line runs on a different thread because it can jump into one virtual thread to another virtual, right? One platform thread to another platform thread, because meanwhile it was sleeping, so it was suspended. But inside over here, if we have a synchronization block like this, the classical way we do, we have a problem over here. That's one of the limitation, which is if we run this, and I will preview over here. Let me do that. Okay. So if we run it, we'll see. It didn't switch. Yeah. That's one of the limitations. But this problem can be solved using reentrant log. Basically, if we use reentrant log, this will not happen. It will be able to switch. So that's one of the limitations. It gets pinned on a platform thread. So maybe we should not use, if you want to use virtual thread, probably because this problem is not solved yet. So that we have to keep in mind. So if we use the re-entering log over here, this is not gonna be a problem. Also, if we want to call a native, native, for example, C code with the JNI or something else, that's where also it's going to be a problem. But there is an effort going on in the JDK, which is they are replacing all this native code call with the Java code. Maybe that's going to go solve that problem. But for now, we have to live with that limitations so far.
Okay, super. Thanks, Professor.
All right. Any more questions? All right, there are certain limitations. One is that what I have just explained, and there are other limitations, which is the size of virtual stack size can be shrink and grow, and it can grow a lot. So if we have a huge stack, something like that, there is an image, it's a huge stack, right? If we have a lot of virtual thread with this much of a stack, it's going to be a problem, right? Because we have to store those stacks somewhere, right? So for simple task, it's fantastic, but for if we have an operation which is a huge call stack, that's definitely going to be a problem. And also since the virtual threads are allocated on the heap, not on the stack. I mean, on the platform thread stack, it's on a heap, so there will be additional work for GC to garbage collect them. So there will be a bit of pressure on a garbage collector as well. And secondly, the other thing is you should not do any CPU intensive work with the virtual thread. The reason is if you do that, there is a pretty much no difference between traditional thread and then virtual thread, because it's going to keep running. Since there is a no blocking operation, virtual thread will not be suspended, and then other virtual thread will not get chance, so they will be starving. So that's another caveat. You should not do that. And the other problem is the preemption, right? Traditional or classical thread, which is platform thread. Sorry, I'm mentioning a lot of words. All of them are same, which is classical thread, native thread, platform thread, carrier thread. All of them are same things. So I'm just using random names. They support preemption, right? If a particular thread is running for a while, scheduler can suddenly stop that. Or but for a virtual thread, it's not yet done. So maybe in future they're going to add it. So that's another limitations. And also we cannot create virtual thread using constructor, public constructor. I don't think that's a problem. It's more easier using
did you see the form, raffle form, and the number of people on it?
Sorry, I missed the questions.
Yeah, no, that I had my microphone on. That was my bad.
Okay. All right. So also, priority. You cannot change the priority of virtual thread. You cannot do that. And virtual thread all are daemon thread, so you cannot create non-daemon thread with the virtual thread. So also, you cannot add virtual thread on a thread group. I'm not sure that's a limitation because I never used thread group, but I guess many people use that, and you should not pull virtual thread as well. So pulling concept, it's definitely if you use virtual thread, you don't need to pull virtual threads. Sorry, you need to create a thread pull. All right. And then there are things you can definitely discuss or argue which is better, stack or heap memory. It's up to you. I don't have the answer. All right. So there is a huge questions. I mean, this is a common question, right? I mean, everyone asks that. Like, do we need reactive programming now since we have a virtual thread? This is a discussion going on. I heard, or if I mean, some people say, I mean, there's a two group, definitely. There's, some people, say that definitely, reactive programming is going to, see the sunset because we have now virtual threads. We don't need to worry about blocking operations. Why, we are not going to spend time on, learning a new things, or, it's definitely not that much readable compared to the traditional way of, imperative code. But again, there are other problems, which is, that doesn't solve, virtual thread doesn't solve the other problem. For example, break pressure, change propagation, composability, all of those things are nice and effective in the reactive stack. And especially some developer really like those things. So there's certainly two groups out there. All right, there's some resources that I would like to share. I mean, I'm going to share this whole deck with you, so you can definitely, get those resources. So that's all the material I had, and thank you.
This is awesome, Baslor. Thank you very much. That was what a great overview you provided for us today on this. Yeah, and I'd like to carve out some time to work with these examples and get a better idea myself on how to work with this. So because this will, like I said, this will be part of the language. So awesome. Again, if you think of anything, other questions, please chime in or put it in the chat. We'll keep monitoring. So while we're waiting, Baslor, if you don't mind, I can like to share my screen.
Sure.
For the rest, and make sure I'm on the right page here. So, all right, cool. All right, cool. Let's see. So, let me put my camera back on too. Oops. Yeah, man. Where the heck is it? Let me stop sharing for a second here. There we go. Start the video. There. Okay. Now we're back. All right, cool. All right. So here's where we left off before we started. So we have some upcoming events, and the most exciting news is a Java Day, and this is sponsored by Oracle. And Billy Corando, who's a developer advocate over at Oracle, reached out to myself and the leadership about hosting a particular Java Day. So this is going to be a series of, half-a-day events, featuring 2 or 3 Oracle speakers, I should say. We have set aside Saturday, September 17th. Yes, it is a weekend. However, I don't know if anybody would want to be around for 4 hours after work. That's which is the reason why we chose a Saturday. We are looking at a couple of different venues, so a lot more information to come, and we're looking forward to being part of this. Oracle will provide food, swag, and whatnot. You'll be able to hear a few speakers on anything Java related, especially, with JDK 19 coming out 3 days after that. So yeah, it's, if you're on my email list, we'll obviously put it on Meetup and, and all that kind of thing. But if you're already interested and you want to save the date, we're probably going to target maybe, after lunch, something like that. But again, to be determined. There's also something coming up next Tuesday, or I guess 2 weeks from today, through SD Times, writing a year's worth of code in 8 hours. So there's a link right there if you're interested in at least taking a look and considering participation. This was from one of our members, reached out to me and let me know about this one. upcoming meetings for us, we are going to take a summer break in August. And we'll resume a month and a day from today. And we're going to have Andres Almaray talk about JReleaser. This is a open source project that he himself, I think, has mostly done, most of the work. He's had some other contributors. And this reached 1.0 a couple of months ago, and he's got a 1.1 as well. So this is a way to release, to provide a release mechanism for your project. If you go to InfoQ, one of the other Java editors wrote about this. You can find out more. And then we're happy to have Nikolai Parlog from Oracle. And he is going to present Java Next from Amber till Valhalla, from Panama till, oops, I messed that up. There's supposed to be Loom in there. so it's amazing how many times you catch an error when you read them. But yeah, Loom is obviously one of the others. So, those are the 4 big projects, in the Java space right now. There are a bunch of others out there. I recently learned of one called Lilliput, and this has to do with the overhead in the programming language itself. So, and then on election day, we are going to have some lightning talks. We're discussing this in the early stages. And, this will be a chance for people to, do a quick 10-minute talk on a topic of their choice. So that's what's coming up for the rest of the year, except for December. So stay tuned. The website will be updated, Meetup, my emails that I send to our distribution list. Friends of JSJUG, the Thursday coming up, the New England Java group has Craig Walls, who will present Put Your Best Boot Spring Forward, and some best practices on Spring Boot. You may know that later this year, Spring Boot 3 will be released, and this is going to be very significant because of JDK 17 will be a minimal Java version for that, among other things. Next Tuesday, Buzz is going to be reprising this talk at the Philly group, so a week from today at 6:30. The Kansas City folks, they're going to have Simon Ritter, as you all know, who presented at our group sometime last year or earlier this year. And it's the art of Java language pattern matching. And you can visit that link to find out more. And our friends at Chicago, they're going to have Kubernetes native Java with Quarkus. This is an in-person and a virtual. And it's part of the Quarkus World Tour. So they'll have Daniel O and Jeff Beck be presenting there. Kansas City did a very similar thing last month. So we'd like to get together with them and maybe sort of, learn from what they did and provide some, offer some kind of hybrid or meetings in later this year. So, all right. So where are we with the giveaway?
We have a winner.
Oh,
and
okay.
I have the winner's email address. I don't have the winner's name, but I can read out the email address and we can proceed from there.
Okay.
K. Rovidilipsrinovas.
Oh, okay. I see here on the Zoom, Dilip Srinivas Krovi.
Yes.
That's you.
Congratulations.
All right. You have a.
Thank you.
You will get a coupon from me. It's a PDF version that you can use to redeem that license. The coupon, just keep in mind that the coupon itself is good for up to, I guess, whatever, probably 2 months at this point, but it's usually each coupon is, you'll have a number of, you'll have some time to redeem it. So awesome. So you'll get that from me at some point, either tonight or early tomorrow morning. And our usual ending slide is a way to celebrate an awesome meeting that we always have, thanks to our great speakers. So Bazlor, thank you very much. You can read some of Bazlor's InfoQ news items on InfoQ. Just do a search on his name, and you'll see what he's contributed so far. So any other questions, comments, gripes? Praise, of course, is always welcome. So.
There is a questions BJ asked. I don't know about the answer, but if anyone of you know, please feel free to share that.
Yes, I meant to say that we had VJ's comment in there. I forgot. I'll stop sharing at the moment. So yeah. So anything else? Please let me know. Please send us email at info@jug.org. If anyone is interested in presenting, we're more than happy to allow anybody to come and take the stage for a couple hours. Just send us an email and we can schedule that for you. So I don't know, anything else? Leadership, Barry, Neha, Caitlin?
Nice picture.
Not on my end.
So,
oh, you know what? Actually, let me turn on my camera here for a second. If I've not spoken with you before, you may not know this about me, but I run a recruiting company for early stage startups. And right now we have a client that's looking for a senior Java engineer as well as an iOS engineer working in Java and Kotlin. So these are 100% remote jobs with equity, definitely above average compensation. If that interests you, I'll throw my email address in the chat. Feel free to reach out. Thanks. That's all on my end.
all right. All right. Well, if there's nothing else, folks, enjoy the rest of your summer. It's always important to spend time with family and friends and take a break from work. Yeah, and we'll see you in, what's that song? See you in September. Well, for those of us who might be old enough to know that one. So, but in any event, we'll talk to you then. So.
Yeah, thank you, Mike, and everyone.
Thank you very much, and we'll be talking, of course. So, all right.
All right.
Take care.
Bye.
Bye.
Take care.